Good morning. I know you guys missed me. Sorry it didn't work out that I'm not here, but I hope you had a restful week. Let's get our lesson started. Get your brains rolling with math again, okay? All right. So you guys, you know how we've been doing linear systems before you guys left for choose off, and it was all about solving for two variables, right? Two unknowns. But now we're gonna add another variable, three. Okay, three variables. So you guys get started, okay? But first of all, what does it mean? When you were solving for linear systems, what did it actually mean? It meant that you had two unknowns, and that means two lines, and you wanted to find the point of intersection, right? But now you have three points, three to find, okay? So let's get started, okay? It's easy peasy then, okay? What happens when you add another point to 2 points to create a line? You get a plane. So let's see what it means to mean. What does it mean to be a solution with three variables? So I kind of drew a XYZ plane here, XYZ 3D plane, but you guys don't worry so much about this, but this is essentially what we're doing. So let's think about it, okay? So I have these three images here, okay? Three planes. I think you remember planes from geometry class, right? So you guys, three planes. Make sure you guys write 3.5 for the lesson, and it's October 5th today, all right? So you guys, we have three planes. We have plane A, plane B, and plane C. Are they all intersecting here? It's harder to see here, but you can see that this one's in the back, and he's intersecting with A is intersecting with B, and B and C are intersecting, but A and B are not intersecting. Therefore, this is no solution. Because in order for remember two linear systems to be intersecting, that means both of them had to meet at the same point. Now for three, all three planes have to be intersecting. This one's more obvious, right? There's plane A, there's plane B, and there's plane C, right? And these planes don't intersect, but we know that A and B intersect and C and B intersect. But because A, B, C, and don't intersect, this is why also no solution here. How about here? That's an easy one. Plane A, plane B, plane C. We know none of them intersect because they're all parallel, so it's no solution. So now let's look at some ones that have solution. So here we go. Now these ones clearly have an intersection. You see at this point here, these three planes intersect. Plane A, plane B, and plane C. They intersect. You can see all three of them intersecting, okay? How about here? That's clearly also. This is a case where this guy A, plane B, and plane C also intersect at a line. Do you remember the theorems and postulates in your So this guy intersects at a point XYZ, but these three planes intersect in a line. You see that here, okay? And obviously planes, right? Planes, you guys, are indefinite surfaces, right? So that's why this line, it's not really a line, but you have to envision it going on forever, so it actually intersects at infinite points, all right? All right, so you guys, let's keep going. All right, here's part two. So you guys, now let's actually solve them. And you sort of solve them the same way that you actually solve linear systems, but a little bit different. We just add another extra layer, okay? So you guys, we're going to solve this one together, number 23. All right, so you guys, we can do it by substitution. Okay, we're going to do same thing, elimination or substitution. We're not really going to graph these though, okay guys? So now I'm going to put some numbers by these equations. 1, 2, and I'll always keep them in these parentheses and try to keep them orderly, okay? You choose one equation to work with, but you use the others to help it out. So for example, since we're doing substitution, you can see how t is equal to s plus r is equal to 3s plus 1. So we can use those to help out with equation 1. So we're going to start with equation 1. 5r minus 4s minus 3t equals 3. That's equation 1. Now what we're going to do is we're going to use equation 2 to plug in for t. So let's try that, okay? So 5r minus 4s minus 3. What's t? T is s plus r according to equation 2. So that equals 3. Now when we simplify that, we get 5r minus 4s minus 3s minus 3r, which equals 3. Okay? Now, when you simplify that, you get 2r minus 7s equals 3. Now, that's a new equation, so I'm going to actually box it, and I'm going to put a number by it, 4. Equation 1, 2, 3, and this is our new equation 4. But now we're going to actually take equation 3. See, we're going to take equation 3, which is r minus 3s equals 1. And look, you guys, now we have two equations that we can work with, the same variables, two unknowns. So now we just have to apply elimination to that equation. So let's do that, okay? So we're going to multiply this sucker by negative 2. Let's do it by negative 2, okay? But however you want to now, okay? So I'm going to rewrite these so it's very easy for us to see. 2r minus 7s equals 3. Negative 2r plus 6s equals negative 2. And what do we get here? We get that negative s is equal to negative 1, or s equals, oh, sorry, you guys. We'll solve this and we get s equals negative 1. That's our first variable that we found. But you guys, I forgot to tell you guys, whenever you're solving a variable of 3 equations, what you should start out with is put it in alphabetical order, R, S, T. And this is the way you're going to find your answer. So as you find your answer, fill in the blanks here. So I like to do that. So we found S, so I'm going to put negative 1 right here. We found S, okay? That's fine. Now we got to find T and R. So let's actually go here. Well, we know S, we have R. So we should use equation 3 to plug in for S. So R is equal to 3 times negative 1, which is what we found, plus 1, which is R is going to equal negative 2. So we found this guy. So R is negative 2, so I'm going to plug it right here. Now we have to find T, right? So T is here. Equation 2 conveniently says T is, right, S plus R. Well, what's S? Negative 1. What's R? Negative 2. So T must be negative 3. So now we're done. Negative 3. Okay? So you guys go ahead and try that, okay? Alright, try that again and watch it again if you have to. Okay, I'm going to try another example for you. I'm going to take it off. Alright. So you guys, let's try this example here. Now we're going to do this by elimination. Your favorite method. But I know that any method actually requires a little bit of elimination, okay? So let's do this. So again, we're going to name these equations 1, 2, and 3. Alright? So you guys, 1, 2, 3. Ready? Here we go. So I'm going to use equation. Let's actually look at all the equations and see which ones can I combine? Which ones can I combine to actually eliminate something? So I could already see that x, y, the same variables, right? Equation 1 and 3 have something in common, equation 2 and 3. So there's many things that you can do. There's so many different ways to actually solve this too. But I'm going to conveniently choose equation 1 and equation 2. So I get x minus y plus z is equal to negative 1. X plus y plus 3z is equal to negative 3. And what I'm going to do is I'm going to try to get rid of one of the variables. Which variable? Well, y is very convenient because I can just add them together. So what I'm going to do is just add 1 and 2 together. So I'm going to just add 1 and equation 2. So I get 2x plus 4z is equal to negative 4. And that's my new equation, so I'm going to call that equation 4. Alright, well that step is done. Let's go on to, now let's look at equation 2 and 3. Is there a way I can get rid of the y so I can get it in terms of x and z? Just like this one. So we're going to do equation 2 and 3, and we're going to combine them together. So I'm going to conveniently write them again. 2x minus y plus 2z is equal to 0, and I'm going to add them. Add 2 and 3. And when I do, I'm going to go up a little bit, guys. Can you guys still see? 3x plus 5z is equal to negative 3. I'm going to box that and call that equation 5. Alright? Now, what do I do with all these? I'm going to combine equation 4 and equation 5, and I'm going to write them on top of each other so you can see what to do next. This just becomes section 2(1) and 2(2), 3(1) and 3(2). So 3x plus 5z equals negative 3. And I think you can figure out pretty much what to do here, right guys? What would I do to this guy to get rid of one another? So let's get rid of the x's, yeah? So I'm going to get rid of the x's. I'm going to multiply this guy by negative 3, multiply this guy by positive 2. And when I do, I get negative 6x minus 12z is equal to 12, and 6x plus 10z equals negative 6. Alright? So when I do that, I get negative 2z is equal to positive 6, so z must be negative 3. Uh-oh, I forgot to start my problem again, right guys? I need to always start with x, y, z. What is my x, y, z, right? I so far have found z, so I'm going to put negative 3 here. Alright, I found it, okay? Now to find x and y, then that's the easy part. So let's go to equation 4. You guys, look, if you take equation 4? It's the new equation that you found. Can't you find, you know z, so you can find x. So let's go to equation 4. Equation 4 is 2x plus 4z equals negative 4, right? So now you know, oh, I know 2x plus 4 negative 3, that's z, right, is equal to negative 4. And when I solve that, you guys, x is going to equal 4. Because it's negative 4, negative 12, positive 8, divided by 2. So it's going to be 4 here. To find y, it's even easier, right? Because now everything is pretty much set for you. You can choose any of the following first two equations. Which one do you want to work with? I think I want to work with maybe the first one, okay? So I'm going to work with the first one to get to get y. So let's plug it into the first one, okay? Equation 1, can you guys still see that? Negative 1. Equation 1, okay? Which is x minus y plus z equals negative 1. So now I know 4. So x is 4 minus y. I don't know what y is, but plus z. Z is negative 3. Plus negative 3 is equal to negative 1. So y must be 2. So you guys, 4, 2, negative 3. These intersect at 4, 2, negative 3. Okay? So that's that. Let's try a few more, yeah? So you guys, we're going to try one that's a little bit longer. Make sure you guys stop the video at any time, okay? Because I'm going to try one now that you can use any method, okay? Alright, so let's go here. Let's go to, this problem here. Where'd it go? Let's go here, okay? You could use any method here. So I was going to have the big hand people solve it if you were working together in class, but since I'm not there, okay, we can't. Let's actually do it this way. Now you look at this, okay, we're going to just do it my way, all right? So ignore that. But you guys, we could use any method. I was going to have you guys try both methods, but you'll see how substitution, if you try it, okay? It's going to be kind of tough because substitution creates fractions. So you look at this and you're like, well, I'm going to use elimination. So let's do it by elimination again. Okay? Which equations do you think you're going to use? Let's check, okay? So here's equation 1, 2, and 3, okay? We're going to get rid of, let's see, which equations? Let's try these two, yeah? Let's try 1 and 2, okay? 1 and 2. We're going to rewrite it. 4x minus y plus 2z is equal to negative 6. Negative 2x plus 3y minus z equals 8. Well, what are you going to get rid of? Let's get rid of x. You know why? Because then this is written by y and z. So we want both of these to be written in forms of y and z. So let's actually multiply this guy by 2, yeah? Because it's going to get negative 4, which when we add together, we'll get rid of the x. So I like to rewrite the equations, you guys, but you don't have to. So that's the first equation, negative 6, and we have negative 4x plus 6y minus 2z is equal to 16. And when I solve that, I actually get rid of x and z. So that's going to be 5y is equal to 10. Therefore, y is equal to 2. But you guys, I forgot it again. Always start with your x, y, z is going to equal x, y, z. Plug it in. Y is 2. So plug that in, okay? Now, we found y already, so let's actually use equation 3 to find z. 2y plus 3z equals negative 5, right? Well, we know y. 2 times 2 plus 3z equals negative 5. That means z is going to equal, let's try negative 9, so negative 3. So it's going to z equals negative 3. So negative 3. You guys, I'm not showing the steps here, but make sure you guys do. So I guess in this case, it would be 3z is equal to negative 9, right? So then z is negative 3. Well, we know y and z, so you can plug it into any of these if you want, okay? So I'm going to choose the first equation. 4x, we don't know. But what's y? We know it's 2. What's z? We know it's negative 3, and that's equal to negative 6 according to equation 1. That's negative 2, negative 6, that's negative 8, plus negative 6. So we're going to add 8 to both sides, right? So it's going to go 4x is equal to 8. So x must be half. Oh, x must be 2, I'm sorry. X must be 2, right? Negative, oh, no, this is actually 2, right? That's negative 8 plus 2, so it's going to be 2. So x is equal to half. So half goes here. So you guys, hopefully that helped a little bit. I really hope so. So I guess try that, okay, guys? Try that. Try the best you can. I also put up some links for you guys to actually watch and actually explore, okay? Well, good luck. I'll do the word problems with you when I get back, okay? All right, bye.